Oh, today I'm gonna show you also the modulation circuit, very simple circuit for educational purpose. I will show you how it's functioning. Here you can see my breadboard. I have put on circuit for temporary purpose, and I have made breadboard circuit type circuit. I have put in some wires. I have used a 5 IC. I have used MOSFET. This is MOSFET controller, so I have used IRF 740 MOSFET and channel MOSFET, and I have connected my DC fan, like it's cooling fan, brushless cooling fan. It's 12 volt basically, 12 volt DC, and 0.2 ampere. You can see here 12 volt DC brushless fan. Current rating is 0.2 ampere. I have supplied power to my power supply. I have connected 12 volt here, but as you can see here, my multimeter, I have supplied only 9.6 volt to the fan. It is connected to the output of the fan unit, and as you can see here, there's a 9.4 something voltage here also, and there's a pulse modulation. If our pulse modulation, if I increase or decrease the speed, so you can see with this variable control potentiometer, if I increase or decrease, my duty cycle will be changed also, as well my fan speed will be slow also. So I have connected, you can see here, so I have connected my scope meter. For learning purpose, very good scope meter, entry level meter, and I have connected here positive and negatively the diode, which is I connect reverse the motor polarity, so it will not come in reverse voltage and your feedback. Those feedback voltages. And I have connected my Fluke 875 2RMS multimeter, which is very high level industrial based multimeter, very professional. I have connected. So how you will see here, I have connected the same probe here as my scope meter is, and you can see here the fan is running, spinning very fast, approximately not at the full speed. If I increase my full speed, you will see the voltage will be increased also, and the sound will be changed as well. Now it's working on 10 volt, and you can see the speed is also increased, sound will change. Now if I want to check my duty cycle and frequency, I can press hertz. Now it's in 10, almost 9 kilohertz frequency, 9.7 kilohertz, and my duty cycle is 93% on and 6% only off, so it is approximately completely turn on, not full on. If I increase my speed more, you can see my duty cycle also increasing, 96%, 97%, 98%, almost 99.9%, 199.54. In this condition, if I want to check my voltages on the fan, it's approximately 11 volt approximately. And if I want to see my fan speed, spinning very fast, and it's approximately full speed. And you see here fan voltage here. Now what I want to do is can see here, I am getting 11 volt DC with my almost 98% duty cycle on. So most of the time the fan is on continuously. If I want to decrease it, you can see it's going down 9 volt something. Frequency also, you can see here's the gap. You can see here's on the screen there's a gap, so it's mean this much percent it's off and this much percent is on. This is my on cycle, this is my off cycle, duty cycle. If I decrease more speed, you will see my off duty cycle will be increased also, and my speed as well as going slow, and voltage also decrease. You can see here. If I make it to almost, if I want to check this condition, I will check my duty cycle and frequency. So 46 kilohertz and it's 69%, almost 70%. 70% is approximately on. 70% slope, positive slope on, and my how much. If I want to check my passive modulation properly, this multimeter is 200 multimeter and it's very nice professional multimeter. It has so many features, so I can find a lot of things in signals and voltages and everything, and it's very accurate as well. So so I want to check my, this is, now you can see is a positive duty cycle, and if I decrease, if I change this button, is 30% is off, negative peak, negative slope is 30% off, and 70% on as well. Approximately on positive cycle, negative 30% off slope, negative slope, and this positive slope. Now I change to voltage again. As you can see, the fan is spinning slightly slower than before. If I find my frequency positive modulation also, it is 70% on, 30% off shortly. If I increase it, you can see if I want to decrease the value, I want to check till what speed it will work. So I have to go more down, 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 down. Approximately I want to check with 3 volt. Approximately 3 volt. You can see here it's a 3 volt, and my positive slope is most of the time, my PWM signal, positive signal is most, duty cycle is most of the time is off, and the effect of the fan on this one, it's spinning really slower. And if I want to check my voltage also here, 3.8 volt. If I want to check my frequency, it's 38 kilohertz frequency. If I want to check my duty cycle, it's 40% on, positive, and negative 60% on, 40% off, 60%, 40% off, and 60. Sorry, I apologize. It's a 40% on, 60% off. Duty cycle passive modulation. You can see here it's most of the part. This one you can see here my positive duty cycle is very, so width is very thin, and my negative off cycle duty cycle width is very high. It means our fan is getting 70% time, 60% time it is off, and only 40% time it's on. That's what my speed is also being very slow with the fan. With this circuit we can control DC fans and these things, LEDs intensity and LEDs switch on off switching time, or fan also as well, fan speed and fan on time. But with the, if I connect this DC fan directly to my power supply, yeah, if I decrease this voltage from 12 to 9 or maybe something 8, my fan will be completely turned off with the linear power supply. But with this circuit, with the help of the circuit, my fan is still on with only 3 volt. It is working even until you can see it is 12 volts fan, but it's running on 3 volt also as well. 3.8 volt it's functioning, and even if I want to decrease more speed, it will work also. Let's see what till what speed it will work. 3.4 volt, 3.2 volt, 3 volt, you can see 3.4, approximately 3.5 volt. Fan is spinning really slow, and my duty cycle as well, you can see here my frequency is very slow. I want to increase, I can increase gradually. You can see the voltage increasing, and my pulse width is changed. Most of the time it is on, and less time it is off. You can see here I will increase it to 9 volt approximately, or like this. You can see here 9.2 volt. See here there's a pulse width modulation 9 volt, and most of the time it's my on pulse width is wider than before on 3 volt. So most of the time my fan will be on, and as you can see here my fan speed also very fast. Now thank you very much for watching this video, and hopefully you will learn how pulse width modulation is functioning. It's very basic for new beginners in electronics, or someone who is interested to know. It's very basic circuit. Thank you very much for watching.